Hello data structure students, as promised, here's a little C++ tutorial related to your tokenizer assignment. So first of all, just a reminder, you can use any editor and any compiler that you want, as long as it is standard C++ code. And to get started, we're going to need to have a file to work in. So going to make us a new file, main.cpp. And, per the usual, you're going to want to probably have, your input and output streams, using namespace, standard, and your usual main function. Okay, so right now, this all looks pretty par for the course, nothing terribly surprising. There are other ways to write a string tokenizer other than the one described in the assignment document. That's just a suggestion. You could even go old school C, and look up strtok, which is a really old school way of tokenizing strings, but unless you're really kind of comfortable with working with pointers and those kind of things, I wouldn't worry about it. But the string stream include that we talk about in the assignment document is probably the easiest way to go. And what it is, it's like your typical input stream, like CN or whatever, but it works with strings instead of the standard input, which is kind of cool. That's a pretty powerful advantage. So, how you would set that up is you have to declare an input stream. It's string stream. The example in the assignment document called it SS. You can call it whatever you want, really. But you're going to need to initialize it to some sort of string that that you're going to have that you want parsed. Oh, and a student asked me what the difference between parsing and tokenizing was. And that's a really good question. So, to break a string down into individual components is called tokenizing. To break them down into components and apply some sort of meaning to them that your program or you will be able to understand is parsing. It's hard to parse something. You might hear that phrase, when it's hard for someone to break something down and figure out what it means. Tokenizing is breaking something down into its very specific components. So let's just declare a string for us to work with. We'll call it inString and set it equal to Mary had 5 little lambs. And we'll give that as the input parameter here to SSString. So now you can treat SS the same way you would treat CN, except instead of reading from, the standard input, your keyboard, whatever, it's going to be reading as if you're typing this string. So let's do this. And let's just output the results. Okay, so what we're doing here is we made a test string that we're going to pass into the string stream input stream. And we made another string to read the input into, and then we're just going to output whatever we read in. So let's save this, go over here and compile our code. Oh no! Something horrible happened. I made a typo. And you know what? I'm not editing this video, so you're going to see it. I'm all about being real. Anyway. So, fix our typo. Recompile. Yeah, no errors this time. Let's clear our screen and actually we named it main. So let's run main. It says Mary. Yeah, not terribly surprising. So, the first word in that input stream was Mary. So let's just copy and paste this line over and over a couple times and see what happens. Clear our screen, compile our code, and run it. Mary had 5 little. And if we keep going, add a lot of those, clear a screen, recompile, and run. Mary had 5 little lambs, lambs. Okay, so this behaves pretty much in the same manner that we have seen using CN or FN or something like that in your previous C++ experience. Now, what you want to do, though, is since we don't really know how big our input strings that we want to tokenize are going to be, we kind of want to have some flexibility there, you know? So let's say we wanted to set up our code so that we could detect or read in specifically strings and integers. I'm not going to give you the whole show here. You're going to have to figure out, some of this, but getting you past the hard part here. So while ss.eof. EOF stands for is a common acronym you're going to see. It's going to stand for end of file, and it's a special character that comes at the end of file streams typically, but also at the end of your string stream as well. So what we want to do is, while we haven't reached the end of our stream, we want to keep looping through it, reading stuff in. So now what we can do is we can do ss input. Matter of fact, we're just going to take this code here and put inside of our loop. Fix our indentation so everything looks nice, and let's run our code. Mary had 5 little lambs. Awesome, and not surprising. So what it did, it pretended essentially that you were typing each one of these at the keyboard. Oversimplification, but the analogy works. And so if you were typing at your keyboard and you're using CN, and you typed out Mary had 5 little lambs, and you were using CN, it would read in Mary, followed by had, followed by 5, followed by little, followed by lambs. And so this is doing exactly the same thing, except instead of reading from the keyboard, it's reading this string as if you were typing it from the keyboard. Kind of cool, right? Now, how do we differentiate between different types of data, different strings, floats, ints, whatever, in our input stream? Well, if you're writing this out, we could, let's actually change our names here. Let's make this S input for string input and I input for integer inputs. Well, let's say we were going to try to read in integers. Let's compile our code, run it, and oh no, it broke. Wow, lots of zeros. Okay, so what we did is we tried to read in a type of data that was not the first thing in our input stream. Mary is definitely not an integer. And so things kind of freaked out, and we ended up with this circumstance where our loop never terminated, because it kept reading in 0 because there's no integer there, and never progressing past that one because it never read in an integer. So essentially reading in nothing, waiting for an integer, reading in nothing, waiting for an integer, and it just kept on going. This is where using those try and catch blocks from the assignment document come in really handy. But to use those, we've got to enable exceptions on our string stream. And we do that using this line here, ss.exceptions ios, and that's input output stream fail bit. So we're setting the fail bit for our stream. So if something goes wrong, say we read in something where we weren't expecting to read in, instead of freaking out, and kind of, having these situations occur, it's going to call an exception, meaning we're going to try to gracefully handle the failure of our code. Let's just code and compile. Okay, that worked. Okay, tidy up a bit. Code and compile. Every few edits, just go ahead and recompile just to make sure you didn't mess anything up. And look, something went wrong. What? Oh, I tried to execute it. Okay, so notice now, instead of running over and over and over again, it actually terminated the program. So an instance of input-output stream failure occurred. So now we can take advantage of try and accept. Depending on where you learn to code, some people are very much against taking advantage of the glorious nature of try and accept or try and catch. In Python, it's called try and accept, and in C++, it's try and catch. So what happens is you try this segment of code, and if this segment of code executes perfectly, then well, it happens. But if it crashes for some reason, it goes to the catch block and executes an alternative set of code. We've got to catch an exception, so you can't just have a catch here. You need to catch a particular exception. In this case, we're going to be catching an input-output stream of failure. See that guy right there? That. And we do that by using ios_base failure. So if something goes wrong, really anything at all breaks with this input stream, it's going to chunk this segment of code and go and execute whatever was in here. And so, since the only thing we were doing in this segment of code was reading in an integer, if it failed, then we probably didn't successfully read in an integer, which implies that another thing we could have been reading in was string input. In fact, let's add some output here. String found s input. Let's edit this line so it would tell us int found. Okay. Now let's compile our code. Well, first let's clear the screen. Compile our code and see what happens. What? What? Something weird occurred. Why did this happen? Well, one of the things that you're going to have to do is once that failure bit is thrown, you're also going to want to clear it. So be sure to clear your fail bit. Now let's recompile, run our code, and boom! Something magical happened. We found a string Mary, we found a string had, we found an int. Hey, different stuff happened here. We found another string little, and we found a string lambs. Okay. So this is the extent that I'm going to show you in terms of working out your tokenizer, because all the bits and bobs, all the pieces that you need to put this puzzle together are inside of this. So try to get this going, and if you have questions, talk with me, talk with Mo, and we're happy to help you out as best we can. Okay, folks, hope you're all doing well, staying happy, healthy, and safe, and I will see you in class.